The pressure gradient tool allows you to perform detailed investigation of pressure calculations in your wellbore. With it, you can determine the likelihood of liquid loading, hydrates formation, and erosion. To use the pressure gradient tool, valid fluid properties and a valid wellbore are required. Knowledge of production data is also very useful. Previously, we noted that liquid loading was probable in our wellbore after analyzing our production data in the Diagnostics tab. In this plot, it is easy to see that our actual gas rate, in red, falls below the Turner liquid lifting rate somewhere between September and November 2001. To see more detail, let's pick a specific date, say December 1st, 2001. In the production editor, scroll down to December 1st. Here we can find the key information for further investigation: rates and pressure. We will need to jot down the relevant gas, condensate, and water rates, along with the wellhead pressure. Moving to the Analysis tab, click on the Pressure Gradient thumbnail. A new worksheet is created, wherein we also need to create a new flowing pressure analysis through the plus sign. First, we need to define the wellbore that will be used in the calculation. We will use the previously configured wellbore 2 with the casing-only configuration. Then we will enter the rates. In this case, we need gas, condensate, and water rates. Finally, we'll enter a wellhead pressure. After calculation, the pressure gradient curves are shown in the plots on the right-hand side. Under Curves and Diagnostics, we can also choose to plot temperature or velocity, which are only shown on one plot, the active pressure gradient plot. On the left, the selected pressure gradients plot shows only the pressure gradient for multiple analyses, which is useful for comparison. If we turn up temperature and then turn on unloading velocity, it will immediately show us a comparison between our actual gas velocity and the critical unloading velocity for all depths in the wellbore. The shaded orange indicates a problem, which is indeed what we have. We can also check to see if we have an erosion problem by enabling the erosional velocity calculation. In this case, we don't have a problem with erosion, since our actual gas velocity is much lower than the erosional gas velocity. If we did have a problem, yellow shading would occur. The final option in this list is the hydrates envelope, which will show a blue shaded area if a hydrates problem is predicted. To show hydrates, you will need to know the percentage of propane that is being produced. To alleviate liquid loading problems, a common solution is to add tubing. Tubing reduces the area to flow, which causes the velocity to increase in order to maintain the same flow rate. If we rename the first analysis to casing only, and then add a second analysis with the same rates and pressure, but use tubing flow instead, then we can see that our pressure drop across the system has increased noticeably, but our liquid loading issues have largely been cured. For even finer detail on wellbore calculations, click on the Details button. In this new window, there is a tree view to select from over 60 parameters, a grid view to show the calculated data for each parameter, and a plot view to compare selected parameters. In this example, there are 100 rows, indicating that the wellbore calculation used 100 segments from wellhead to sand face. By the way, a segment is a small section of the wellbore where we assume that certain parameters, like density, remain constant. By having many small segments, we increase the accuracy of our calculation. If I wanted to recreate the unloading velocity plot, I could enable the velocity parameters and then select the gas velocity and the critical velocity from the grid view. Many other parameters can be plotted as desired using the selection box.